Guys, good afternoon. Today we will discuss WKB approximation. Okay, actually this question asks for 12 marks in our regular exam. Okay, the question is asked like explain WKB method for one dimensional case and derive the connection formulae and apply the method of to obtain the quantization condition of for bound state. Okay. This type of question asks for 12 marks regarding WKB approximation. We should have to write the answer of given example or given question. Okay, actually WKB, what is WKB? WKB is nothing but the name of that scientist who discovered the WKB approximation. Okay, W stands for like a W stands for Wenzel, K stands for Kramer, as well as B stands for Brillouin. Okay, the statement of WKB approximation is employ only when the potential is low or slowly varying. Okay. This method is employed when the potential is low or slowly varying. Actually, the use of this method whenever the potential of any system is low or it will slowly varying, at that time we will use this method. Now we should have to prove the derivation of WKB approximation. Okay, according to Schrödinger equation. Okay, you know that what is the Schrödinger equation, which is time dependent or time independent. Okay, here according to Schrödinger equation we can write minus h cross square upon delta square psi of x upon 2m. Okay, as well as v delta h cross minus h cross square delta square psi of x upon 2m plus v of r, then psi of r is equal to e of r and psi of r into psi of r. This is the equation number first. Okay, we should have to multiply the equation. Okay, we should have to multiply by minus 2m upon h cross. Okay, at that time after multiplying this we will get v of r into minus 2m upon h cross square psi of x, okay, is equal to minus 2m h cross square e of r into psi of r. Okay, when delta square psi of x is a after multiplying we will get that delta square upon psi of x plus 2m h cross square e minus vr of psi of r is equal to 0. Okay, when minus 2m upon h cross, this term will be transferred to shifted to this side. Okay, at that time we will get this equation. After that, okay, after that delta square psi of x plus p square upon h cross square psi of r is equal to 0. This is equation number 2. Okay, where according to classical mechanics, you know that according to classical mechanics, okay, p is equal to under root 2m into E minus V is energy and V is voltage, nothing else. Okay, the solution of equation 2 will be, after this the solution of equation will be psi of r is equal to a exponential plus minus I upon h cross p into r. This is the equation number 3. Now we actually in last we will get equation number 3. Now if the potential is slowly varying, then the solution of equation 3 will not be the solution of equation 2. Now at that time we should have to apply WKB approximation. Okay, if we apply the WKB approximation, then the solution of equation 2 will be psi of r is equal to a exponential I upon h cross into s of r. This is equation number 4, where a stands for amplitude and s of r stands for phase shift. Okay, now after that now we have to find out the values of a and s of r. We have to find the values of a and s of r. Then using the known values of energy, where energy E, mass m and voltage V. Okay, now put equation number 4. This equation we should have to put in equation number 2. Then we get delta square into a exponential I upon h cross s of r plus p square h cross square into a exponential I h cross into s of r is equal to 0. Okay, at first we should have to solve this term. Okay, at first we will solve this term, then we will discuss about the next one term. Okay, so consider this term is 1 and another this is 1, this term is second. Okay, now we will solve at first term, that is delta. Here delta square we can also write, this is delta into delta a exponential I upon h cross s of r. Okay, we can solve this term at first. D is delta d, it is derivative, it is also derivative, so derivative into a exponential I upon h cross s of r. We should have to solve this equation. At first we will solve this derivation. Okay, we can multiply using this derivation at first by this delta, then we will discuss about this. Okay, we can write as it is delta here. Okay, when we multiply this here, you know that derivation, there is the formula for u and v, u into v, this is u and this is v. Okay, the derivative of first term we can write as it is. Okay, so a upon I h cross, this is first term, we will write as it is. Then the derivation, we can write derivative of second term, that is s dash r exponential I upon h cross s of r plus a. Now we should have to take derivative of first term. Okay, that means u, this is a dash exponential I h cross upon s of r. Okay, this is the term. Now you should have to give concentration on next term, because the second one term is very hard to learn, or as like you should have to write this equation for 3 or 4 times. At that time you will be memorize. Okay, now the next term is a into I upon h cross s dash of r upon into I upon h cross s dash of r exponential I h cross upon s of r plus a into I h cross I upon h cross s double derivative r into exponential, okay, exponential I upon h cross s of r. Okay, plus we should have to take a next derivative. Okay, a dash upon I h cross s of r exponential I upon h cross s of r. Okay, plus a dash upon I h cross s of r exponential I h cross I upon h cross into s of r. Okay, plus double derivative of that third term, a double dash exponential I upon h cross, it is s of r. Double dash means double derivative. Okay, now we should have to take common here. You know that this term I h cross will be taken as common, and in this term also we can take I h cross as a common. So we will take I h cross here common. After taking common, I h cross upon this term. Now I h cross into I upon h cross a s2 dash. Okay, when we combine that two terms, that s will be s2 dash exponential I upon h cross into s of r, plus when the derivative of second term, this term we will take as it is. Okay, actually this term we will take as it is, a into s double dash of r exponential I upon h cross of s of r. Okay, now plus, now we will make actually these both terms are same, so we can add this term. Okay, now after adding this term, 2I upon h cross a dash of s, a derivative of s derivative of r exponential I upon h cross of s of r. Okay, and this term we can write as it is, a double derivative exponential I upon h cross of s of r. Okay, now after this we have get this term. Okay, now we have to add the second term of that equation. Okay, we should have to add here 4 in equation number 4. We have, this is the first term we have solved, there is also second, that is this term we should have to add. Okay, now we can therefore the equation 5 becomes, if you can multiply this I into I, that is I square, so the value of I square is -1, we can write here. Okay, -1 upon h cross square, that is a s2 dash. Okay, s2 dash exponential I upon h cross s of r plus I upon h cross a double derivative of r exponential I upon h cross s into r, s of r. Okay, now plus now we have to add next one term, that is I upon h cross. We have taken I here I upon h cross here, okay, I upon h cross 2a dash s dash of r exponential I upon h cross s of r plus this term it is as it is a double dash x exponential I upon h cross of s of r. Okay, now here we have to add the second term of fourth equation, that is p square upon h cross square into a exponential I upon h cross s of r. Okay, now we should have to multiply this equation. Okay, we should have to multiply this equation by exponential minus I upon h cross s into s of r into minus h cross square. Okay, we should have to multiply by this term to this term. Now after multiplying the separating real and imaginary terms, we should have to separate the both terms in that equation which are imaginary or which is real. Okay, now after multiplying by this term we get, that is minus this sign as it is here. Okay, the sign minus as it is we can take, okay, of this equation minus 1, then a minus a s dash 2, okay, as or a s 2 dash, that's the same. Okay, now plus h cross square upon a double dash plus p square a. Okay, this term we have taken as it is. After dividing the terms of exponential I h cross will be cancelled after multiplying, then plus I h cross, okay, plus I h cross a s double dash. Okay, this term, in this term we can taken as here, okay, I h cross a s double dash plus twice a dash s dash. Okay, after this is the term I taken as a common, then a s double dash plus the term is 2a dash s dash of r we have taken as it is. Okay, we can we have named this equation number 7, and this equation shows that, now this equation actually equation number 7 shows that minus a s2 s dash 2 of r plus h cross square a double dash plus p square a. Okay, now the equation we can write as it is. We can shift the minus a to this side. Okay, the term h cross square a double dash is shifted to right side, okay, or left side, minus a s dash 2 plus p square a is equal to 0. We have named this equation number 8. Okay, we should we have taken I h cross as a common term, a s double dash. Okay, this term we have taken a s double dash, then 2a dash s dash is equal to 0. This is equation number 9. Okay, from equation number 8 we can neglect the term of h cross square. Okay, after neglecting this term we will get minus a s 2 dash plus p square a is equal to 0. The a has the same term, so we have taken a as a common. Okay, and minus sign shifted to s. Okay, a dash into minus s dash 2 plus p square is equal to 0. Okay, and we know that minus s dash 2 plus p square is equal to 0, and where s dash 2 is equal to s derivative 2 is equal to p square. This is equation number star because it's a main part, so we will show you where we can use the equation number star. Okay, we know that in last before discussing this equation we have write the what is the value of p. Okay, we know that according to classical mechanics p square is equal to twice m e minus v of r. Okay, we know that this term, so s2 dash or s dash 2 is equal to p square is equal to twice m e minus v of r. Okay, now we can write s dash 2 is equal to p square, taking square root of both term, that is s dash is equal to p. Now we should have to integrate this term. Now we will integrating this term, so we get s of s is equal to integration of p of dx. This derivative we have shifted here, and we have integrated this term, so s is equal to integration of p of dx. Now we know that ds square upon dx is equal to p square is equal to twice m into e minus v of r. This is equation number 10. Now for equation number 9 is this as IH cross AS double dash plus twice A dash S dash is equal to 0. This is equation number 9. For this term we can write here AS double dash plus 2A dash into S dash is equal to 0. Now you know that S double dash means d square of S into dx square. S double dash means, so if you are going to solve the above equation, that is A into d square of S upon dx square plus 2 dA upon dx into ds upon dx is equal to 0. Just we have neglected derivative here and we have put the values, that is A S double dash plus 2A dash into S dash of 0. Just we have insert here d square by dx square and d by dA by dx and d into ds by dx. Now we know that d square S upon S is equal to P. So A into dp upon dx plus 2dA upon dx into P is equal to 0. This is equation number 11. We name as the equation is 11. So now we have to divide equation 11 by A. If we are going to divide equation number 11 by A, so we get A as it is cancelled, so we can directly write here dp upon dx plus 2dA upon dx into P upon A. Okay, this A has taken as this A shifted to here. Okay, now is equal to 0. dp upon dx plus 2p, A has shifted to this side, right side, then we get dp upon dx plus 2p, this 2 and p multiplied by, we have taken one side, 2p into dA upon dx into 1 upon A is equal to 0, and name the equation is 12, equation number 12. Now so we have write this equation as it is dp upon dx plus 2p into dA upon dx into 1 upon A is equal to 0. Now we will divide this term by p. Now we get dp upon dx upon p plus 2dA upon dx upon pp, already we have cancelled. Now A as taken here is equal to 0, and we have named the equation is equation number 13. Now rewriting, if we are going to rewrite the equation number 13, so we can take d by dx as a common term. Okay, d by dx as taken as a common term, 2 antilog of A plus antilog of P. You know that the rules and regulations of algorithm that we have learned in 12th standard. Okay, ln is nothing but natural log. Okay, and that natural log is equal to natural log of A plus natural log of P is equal to 0. Therefore d by dx is equal to ln into A square plus ln of P is equal to 0. And we know that the condition is like we have learned the rules of derivation or derivative of constant term is always 0. So we can write here ln A square plus ln of P is equal to constant, and we have named the equation number is 14. This is equation number 14. Now we know that the derivation of a constant term is 0, so we can write the equation number 14 as A square P is equal to constant. Oh yeah, then where A is equal to, we can shift it P to this side. Okay, and A is equal to plus or minus constant upon under root P. Okay, so we will give the name equation number 15 to this equation. Now solution of, we know that the solution of equation number 2 will be psi of plus or minus constant upon under root P exponential plus minus IH cross upon integration of P of x into d of x. This is the equation number 16. Now we can write also psi is equal to constant upon under root P exponential I upon H cross integration of P of x into d of x plus minus constant upon integration minus constant upon under root P exponential minus IH cross integration of P of x into d of x. Now if we are going to solve, if we are going to write the equation is like that, we have taken constant is equal to C plus under root p exponential I upon h cross integration of p of x into d of x plus c minus under root p exponential in bracket minus I upon h cross integration of p of x into d of x. This is the equation number 17. And now we know that if E energy is less than voltage, or E is less than is equal to V of x, then E minus V of x less than 0. This means the particle is in imaginary region. Okay, if the E minus V of x is less than equal to less than 0, then the particle is in imaginary region. So psi of c plus under root p exponential I upon h cross integration of p of x plus c minus under root p exponential minus I upon h cross into I, and the integration of p of x into d of x. We know that the particle is in imaginary region, so we have insert here one more I indicate the imaginary state. So now we can write here also psi is equal to c plus upon under root p exponential I upon h cross into p of x d of x plus c minus under root p exponential I upon h cross integration of p of x d of x. So the point where p of x changes its sign is called turning point. This is this question always asked in MCQ for 2 marks, or it is asked as like a fill in the blank or MCQs, or write what is the turning point. At that time you should have to, if the question is asked for what is turning point, at that time we should have to write the answer. The point where p of x changes its sign is called turning point. Okay, here the p of x will change its sign. At that time we will know the point is called turning point. Okay, when E is equal to V of x, okay, E is equal to V of x, then E minus V of x is equal to 0. E minus V of x is equal to 0. This equation shows that what? This equation shows that actually psi tends to 0. Okay, this equation shows that as E minus V of x is equal to 0. It shows that psi tends to 0. Okay, this means there is a existence of particle. According to WKB approximation, potential must be low or slowly varying. Okay, the psi tends to 0. It shows that the potential must be low or slowly varying. So the solution of WKB approximation will be lower potential or in slowly varying pot is psi is equal to constant under root p into I upon h cross integration of p of x d of x. This is the final equation, or this is the solution of WKB approximation. If the question asks for 12 marks, you should have to write WKB approximation. At first you should have to know what is WKB, what it stands for. Okay, after that, according to Schrödinger equation, you should have to write the equation of Schrödinger equation using that. Then you have to multiply minus 2 by h cross. According to classical mechanics, what should changes you have to do. Then after this you will get actually you have to find out the terms A and S of R. A means amplitude and S means phase shift. You have to find these values using energy, mass and voltage, that is E, M, V. Okay, and after when you are going to solve these values, or finding this value A and S of R, you will get equation. You should have to solve that equation. After solving this equation, you have to write here, you have to separate the terms, that is separating real and imaginary terms. You should have to separate that both terms. After separating these terms, okay, you will get the value of p s is equal to integration of p of x and into d of x, integration of p into dx. Okay, after this if you get this value, then you should have to go further procedure, that is you have to use here natural log. Okay, you should have to divide by this. After that you will get you will get a constant term, and you know that the derivation of constant term is 0. Okay, at that time, after that you should have to put the values of a that is a is equal to plus minus constant upon under root p, that is equation number 15. Then slowly, if we are going to next step, that is the condition, we know that if e is less than v of x, then e minus v of x is less than equal to 0. This we have learned that, okay, before few point. Then this means the particle is in imaginary region. At that time you should have to add one I. Okay, and you know that if I multiplied by I, okay, that is I square, and the value of I square is equal to -1. Now you should have to also learn one thing, that is turning point. Okay, you have to memorize this point, because this is very important point for 2 marks. The point where p of x changes its sign is called as turning point. This is also asked for 2 marks. Then next condition is e is equal to v of x, that is e minus v of x is equal to 0, and you know that psi tends to 0, and this means if psi tends to 0, the existence of particle according to WKB approximation, potential must be low or slowly varying, okay, when psi tends to 0. And if psi tends to 0, the solution of WKB approximation will be lower pot or lower potential, or in slowly varying potential is. And the solution of equation WKB approximation is psi is equal to constant upon under root p into I upon h cross integration of p of x into d of x. If you like WKB approximation, please share to needful person, and thank you.